Okay. Good afternoon, everyone. So welcome to our session for today. We're going to start our discussion on modeling time series using a method that's very popular and let's say a very popular one and a very powerful one. Okay, that model is called Arima, and we're going to explain what an Arima model is. So that's an autoregressive integrated moving average. Okay, so there are some references that I shared with you here. I would strongly encourage you to look at these references. For example, itong reference na to from Pennsylvania State University. They have this. Let me show that. So this is the Penn State University, and they have this very, let's say, very good resource on applied time series analysis. Of course, we cannot discuss everything about time series analysis, but this is a reference. This is an additional material for you to, if you really want to master more the concepts of time series analysis. This resource, this reference will be very helpful. The objectives for our lesson will be more on modeling our time series, and in particular, we're going to make use of a stock. Initially, we're going to model the price of the stock, but usually what's modeled in as far as finance is concerned is the returns of the stock. So I'm going to discuss with you how to model stock prices, and then as an exercise, you'll be asked to model the returns of the stock. That's very easy because you just compute for the returns, and then the modeling will follow exactly the same format as modeling the price of a stock. So there are some terminologies that we should know. For example, this term AR process, ACF, weekly stationary time series. Okay, that's for, in this case, that's for lesson number 1. And then we also have, for example, let me click this. Okay, we have sample autocorrelation function, which if you're a student of a time series, we have to know this. We have to know what ACF is, or PACF, that's partial autocorrelation function. Okay, we have to know what weekly stationary series is. Okay, and also we're going to plot. This is an example of an ACF. Okay, a tapering pattern, and then an alternating and a tapering pattern for an ACF. We're also going to we're going to use an ACF in order to determine what type of model we're going to use. Okay, so aside from an AR process, we're also going to make use to learn how to do an MA process. Okay, so meron tayong AR and then MA, and then yung combination ng dalawang yan, it's called an Arima process. Okay, so let's go back to our file. Okay, so I leave you, class, to look at this. For this one, it tells us about how to write an AR equation. So let me just go through this one, or maybe just this one. I said that this is an excellent resource. Naulit ba to? Oops, sorry. Control Z. Let's just take a look at some of the resources here, which I find very helpful. So I know that you are a type of students who wish to really learn a lot about these topics, especially if you're going to really practice finance someday. Okay, so this is from the Duke University. Kaso nga lang ito, medyo forecasting yung pinaka-ano nito, no? Yung pinaka-focus niya. Okay, and then also, hindi yata ito nag-R, no? So this is, ito lang siya, no? May Arima models dito, so maybe you can take a look at this. Yeah, so the important inputs here are ito, no? Notes on Arima process. Okay. All right, so let's go back to R. And these are the packages that we're going to use. So you have here yung Masyado nagkadikit yata yung mga ano. Okay, some of these packages we have already used before. Let me just separate them. Hindi ko yata na-separate yung... Okay, so this one, we can load it via the Pacman package. So forecast, quant mode, we know already. This is used for downloading data from the internet. Time series, T-series, time series. XTS, that's an extensible time series. ggplot2 is for data visualization, plotting. Orca, this will be used for later on when we migrate from Arima to Guards process. Kasi usually class, pag pinoprocess natin, mag-minomodel natin yung yung mga stock prices and stock returns, they're usually very volatile. So oftentimes, hindi sufficient yung AR process or Arima process. So there's a need to go next step, a step beyond, and model the volatility. Doon papasok yung Urca package, okay? Where we will model yung Garch process. No? Plotly is used to plot your data. Interactive to yung Plotly. No? TSM is also very powerful. Gagamitin natin sa time series modeling yan. Okay? So kindly run this, please. Okay, that's installing already and also loading at the same time. In case you have problems with TSM, okay, I checked this out kasi minsan before when I would load this, nagkakaproblema ako. So I found this another way to load your TSM. You can use the remotes package. Kasi yung TSM, I'm not sure if it's as of this time, if it's housed in CRAN. Diba yung CRAN, Comprehensive Archive Network? So may mga packages na hindi naka-house sa CRAN. So what you have to do is if you need that package, go to the author. And usually yung author, nasa GitHub nila yung package niyan. You can download that and make use of that. So just like TSM, we can, from the remotes package, we use the install GitHub. And then si Kevin Kodzi kasi yung author nito, I'm not sure if it's already housed in CRAN, tong TSM, but if not, kung mag-load sa inyo yung TSM, then okay, ibig sabihin naka-house na kay CRAN. Otherwise, kung hindi, class, we can make use of this. Okay, could you give me feedback, please, if this run, na-install niyo ba si TSM? And then kindly check sa package TSM that should have been already loaded. Okay, here TSM, dapat naka-load na siya. Okay, feedback please. Install, good. Install na si TSM. Ibig sabihin nun, naka-house na siya kay CRAN. Dati kasi hindi naka-house kay CRAN yan, so I had to do this. But since it's already loaded, good, thank you. All right, how about the others? I see only 2 hands. So kindly give me feedback if you were able to download and install the package and load it. So I'm expecting mga 15, 16 responses. I only have 2. So let's wait for the others. Okay, waiting for your chat, please. Okay, thank you, Carla. Thank you. So tatatlo pa lang. Okay, let's give your classmates a few more seconds for them to be able to load the packages. Some of the packages here we're not going to use today, but we're going to use them in the succeeding days. Quant mode definitely gagamitin natin ngayon. ggplot2 and plotly, yes. Okay. Thank you. So a few more seconds, your classmates, and then start. we continue our discussion. Okay, so let's continue, class. Okay, we have learned that as far as data is concerned, you can either have a cross-sectional data, okay, a time series data, and a panel data. What's the distinction between a cross-sectional data and a time series data? Can anyone explain? Ano difference sila? Time series data versus cross-sectional data. Anyone who'd like to explain? You may unmute yourself. Plus, time series versus cross-sectional, and then panel data. Plus, hello. Okay, let me calls for some volunteer. Migs, yes, Anna Grace ka pala ng hand. Migs, yes, what's your...
Hi, sir. The difference between time series data and cross-sectional data would be time series would refer to the same variables of data over a particular period of time, pero the cross-sectional data would refer to a different set of data in a given point in time, sir. If
given
tama
point
po.
in cross-sectional.
Opo, yes, sir.
Okay.
Different data po yan.
Alright. Pwede naman parehong different data yung dalawa, no? Okay, that's partly correct. Only the main difference is that kapag cross-sectional data, one point in time lang siya, no? One point in time and several individuals or several units. Okay? Several units yung tinitingnan natin pag cross-sectional. Example is, kunyari, we're looking at GDP, GNP, unemployment, etc. Kung ano yung mga macroeconomic variables na yan. And then we're looking at only 2023. 2023 or 2022 lang, 1.1. At the end of 2022, kunyari, you're looking at these variables. And then, maraming units. ASEAN, Japan, Korea, India, China, etc. So that type of a data is called cross-sectional data. Okay. On the other hand, so let me just gamitin ko na itong ano. Okay, let me annotate that. No? So for example, we have here, say GDP, GNP, okay, unemployment rate. Okay. So you have different countries, country 1, country 2, country 3, country 4, country 5, etc. And all of this are taken, kunyari 2022 or 2022, yes, end of the year 2022. This is an example of a cross-sectional data. So cross-sectional data to. Cross-sectional data, you have several individuals or several units, okay? And you have several variables, but it's taken only at one specific point in time. That's a cross-sectional data. On the other hand, kapag time series naman, okay, you may have several variables here, okay, GDP, GNP, unemployment. Pero, let's say you're taking it 1978, 1979, 1980, hanggang 2022, no? Across several points in time. Okay, kaso, ang tinitingnan natin Philippines. Okay, so one unit, one individual, one unit, several variables, pwede, several points in time. Okay, so that's your time series. Your cross-sectional, as I said, you have several units. Philippines, Malaysia, Thailand, Singapore, yung ASEAN. Several variables. However, only one point in time, several points in time. Okay? One unit, several units. That's the difference between your cross-sectional and time series. Now, a combination of these two is called your panel data. So panel data is the, let's say, ito yung pinaka-rich, robust na data. Kasi ang tinitingnan natin dito, several points in time, several units. Okay, so for example, Philippines from 1978 to 2022. And then Malaysia, 1978 hanggang 2022, etc. Okay, so you have several different time series. No? Iba-ibang time series, tapos iba-ibang cross-sectional siya. So pinag-combine natin siya, you have now your panel data. Okay, so I hope that's clear, no? I hope clear sa atin kung ano yung time series at saka yung cross-sectional at saka yung panel data. Okay, could you kindly confirm, class, kung naintindihan natin yung difference ng time series, cross-sectional at saka panel data? Paki-chat naman please. Okay, thank you. Thank you. Okay, how about the others? Yeah, salamat ha. Okay, good, good. All right. Yung iba hindi pa sumasagot ha. Sana sumagot lahat. I hope everybody answers. All right. So, saan na ba to? Okay. Going back here. Now, how do we model time series? Kasi ang time series, class, what are the things we can do with that? We can try to come up with the model, okay, to explain how your time series is performing or how it is behaving. So that's one aspect of time series analysis. Come up with a model, okay, to explain your time series. And secondly, also for predictive purposes. So not only explain, okay, not only describe your data. So take natin to. So ito, no? By exploring, okay? So exploring would like to extract meaningful insights from the data and also for forecasting. Exploring, describing, and forecasting. So we can, let's say, estimate, we can predict what will be the unemployment rates, what will be the GDP in the next, let's say, in the next 2 years, 3 years, etc. And we see that being done by economic agencies. No? Si NEDA, ginagawa yan, nagpo-forecast ng GDP, etc., GNP. Okay. All right. So there is a method that we can use in order to forecast or in order to come up with a model for time series. And that approach is called the Box-Jenkins approach. This was developed in 1976. And even up to now, gamit na gamit pa rin siya. Of course, there were some changes, may mga improvements dun sa approach na to. Pero yung fundamentals niya, ano pa rin? Yung existing pa rin ngayon, ginagamit pa rin ngayon. And among finance and economists, very popular tong Box-Jenkins approach. So what's this? The Box-Jenkins approach, okay, makes use of what we call an Arima process. Ito. Arima. So what's Arima? It refers to autoregressive and then moving average. Okay? So this name, yung autoregressive, class, very self-explanatory to eh. Kasi auto, the autobiography, auto sign, okay, autograph, you're doing it yourself. Self yan, ibig sabihin ng auto. So ibig sabihin ng auto-regressive, you are creating a model, for example, X sub t, may time series ka, X sub t, tapos gagawa tayo ng model na parang regression siya where your model makes use of X sub t values mismo. Pwede yung past values niya. Kaya X sub t minus 1, X sub t minus 2, etc. That's what we mean by autoregressive. You use the values itself of the time series. in order to predict or to model your time series. Okay, there's another method called MA, which is past error terms. Okay, so medyo tricky yung pag-define ng past error terms. So, i-explain natin next time yan. Yung autoregressive, madali eh. Madaling i-explain kung ano siya. Pero itong MA, ano yung past error terms? Does that mean magre-regression muna tayo tapos kukunin natin yung error terms siya? Not necessarily, no? So medyo tricky itong MA na to, yung ibig sabihin ng past error terms. But be that as it may, just understand muna na error terms, no? Okay, so that's the difference between your actual and a particular value, no? And then you have your I here. That stands for your integrated, no? So I'll explain in a while ano yung ibig sabihin ng integrated dyan. Okay, so continuing, dito. Okay. So, ito, no? So let's first write let's first take a look at autoregressive. Okay, so ano yung ibig sabihin ng autoregressive? So, ito ginawa na namin sa kabilang section. Let me just flash this. And I want you now to, sige nga, subukan nyo class as an exercise. How do you write this in LaTeX? You should be quite familiar with LaTeX class. That's one skill that's important for us to learn. Okay. So this one. Yan, ito, class. So this is an AR1 process. And why is it an AR1 process? You have this series x sub t. So this is your time series. And it's equal to a certain constant, delta, plus the coefficient phi1 of x sub t minus 1, plus a certain error term. So this model is what we call an AR1 process. Okay? So I want you to write now, para practice nyo, ito. Sulat nyo nga ito, class. And please chat kung nasulat nyo na. So that will take care of the writing in LaTeX, the model for AR1 process. So that's x underscore t. Ito yan, no? Di ba? Your underscore is dash or underscore t. And then slash delta, that will write your Greek letter, slash delta plus slash phi. This is your phi. And then underscore 1. So that's your subset, subscript. And then x underscore t minus 1. So your t minus 1 is as a subscript plus epsilon e. You can write here this, you can write this as epsilon if you want. Epsilon. So magiging ito siya, epsilon. Okay? Pwede ring e na lang to simplify, but you can write this. All right, then if you're done, kindly chat please kung nasulat nyo na. If you were able to write it. So parang practice nyo na rin. I don't want to give it to you kasi gusto kong makita nyo, ma-practice nyo rin kung paano sinusulat yung itong mga formulas, no? Okay, thank you. All right, good. Good. Instead of me just giving it to you, I didn't want that. Nagkamali ako dun sa isang section na nabigay ko sa kanila. So I forgot to erase it. But this time here, iba yung kayo mismo nagsulat eh. Okay, so we have this AR1 process, no? So ano yung AR1 process? First order autoregression model. First order, why first order? Kasi you are regressing, you are coming up with a model x sub t where it is regressed, okay? It is modeled on x sub t minus 1. This is lag1, lag1. Okay, so let's illustrate that a bit. Okay, thank you. Okay, kunyari meron tayong data, no? So, ga-annotate lang ako. Let's suppose this is our x sub t. X sub t, sabihin natin ang values natin, 99, that's 97, tapos 98, tapos 100, tapos 96, tapos 96 ulit, ganyan, okay? And this is, let's say, i-rearrange ko lang Let me call this value t, yung most current, T-1 yung kahapon, T-2 two days ago, T-3 is 3 days ago, etc. So usually ang data naman baliktad eh. Yung pinaka-earliest yung nauuna. But let me just, for purposes of illustration, use this. Okay. Ano ibig sabihin ng xt-1? So you're using this xt-1. Okay. Ano yung xt-1? Log 1. So that means 97. Yung one period before, and then 98, and then 100, and then 96, and then 96, etc. In other words, tinanggal natin yung current. This is current, this is x sub t. And then what I did was to create another time series. Yung time series na yun, x sub t minus 1. Okay? So now, you have this time series x sub t, and then you have this other time series x sub t minus 1. So you are creating a model for x sub t based on log 1 values. Kumbaga parang regression, ang kinukuha natin yung past values niya. Now, my question lang ako, class. Will this make sense in a cross-sectional data? What do you think? Will this make sense in a cross-sectional data? Okay ba mag-auto-regression AR1 sa isang cross-sectional data, class? What's your opinion on that? Hello?
No, sir.
Why?
Why? No.
Okay, thank you.
Thank you. Thank you for that.
Why no?
Sir, because it's they're different po, the cross-sectional and time series.
Yeah, they're different. So in what way are they different? Why doesn't, you're correct, it doesn't make sense to do an autoregressive model in cross-sectional data.
Yes, sir,
Bakit
because
kaya?
with time series po, it's just one unit or one individual, and you're checking it throughout different time periods po. But then for
Okay.
cross-sectional, it's different units or different individuals in
Okay.
one time period po.
So what if it's different individuals? Ano yung doon? Ano yung catch doon? Kasi pwede rin namang di ba, kahit ibang individuals, then ang gagawin ko susunod, kunyari itong Philippines, itong Thailand, itong Malaysia, di ang mapupunta dito ngayon, mawawala si Philippines, magiging Thailand, Malaysia, etc.
Yes, sir, the data will be different po for each.
Ganun din naman si di ba, si time series, magiging iba na to, no? Kasi itong T-1 magiging first na siya dito, ba?
Yes, sir, but it's observing the trend of one unit pag
Okay.
time series.
All right.
Time series.
So
But then,
yeah, thank you, Carlos. That's correct, no? Sa time series kasi, class, structured yung data na yan. May order yan. It has an order. And it's possible that the values yesterday has an impact on the value today. Ang cross-sectional data, kung baguhin natin yung order, di ba? Wala namang wala siyang logical order eh. Di ba? Hindi naman ibig sabihin Philippines, tapos Thailand, tapos Malaysia, tapos Indonesia. Kung baguhin ko yung maging Indonesia, Philippines, Thailand, Malaysia, mag-ano ba? Will that affect your data? Hindi. Kasi wala namang logical order ang cross-sectional data, di ba? Unlike itong time series, hindi pwedeng T tapos ito magiging T-10, tapos T-20, tapos T-5. Hindi pwedeng ganun. A time series is a structured data. Okay? So may ibig sabihin itong x sub T-1. Alright? So that's why, class, an autoregression model will make sense in a time series but not in a cross-sectional data. That's why we don't use AR1 for a cross-sectional data. Kasi wala naman sense yung ordering nun di ba? Pwede nating i-jumble yun, pwede nating alphabetical, pwedeng whatever method of ordering it. A time series is not like that. A time series has an order to it na hindi natin pwedeng baguhin yung order. Okay, so that's the reason. Thank you, Carlos, for that, no? So, yun ang ano ko, class yung question, no? An autoregressive model can work for a time series, but not necessarily for a cross-sectional data. So you don't hear of a model sa regression, no? Cross-sectional data. Hindi ka makakarinig ng autoregressive sa ano sa multiple linear regression. No such thing. Okay. So I hope that's clear, class, no? All right. Now dito, I think you have this also. May assumptions tayo dito, no? We have certain assumptions here. Okay, ano yung assumptions natin? Dito sa model na to, okay, yung error term natin dito dapat independently and individually, okay, distributed, normal distribution siya dapat siya with mean zero and constant variance. Okay, ito yun, no? I already gave that to you. Okay, ito. E sub t, okay, ito yung overset. Yan. Overset siya. Ito IID yun, nasa taas yung overset, no? IID. Ito yon, overset. And then ito naman simulates, no? Ito. Yung slash sim, ito yon. Okay, and then we have n 0, comma sigma squared w. Okay, so that's the way to write this notation in LaTeX. All right, so ano ibig sabihin nito? The error should be independently distributed. Dapat yung mean zero, at saka dapat constant yung variance niya, which you learn in regression, di ba? Dapat yung variance niya, dapat homoscedastic yun. If you're going to create a model, yung error term na to dapat homoscedastic siya. Okay. Then also, meron pang ano dito, something that's not true for cross-sectional data. Yung phi sub 1 na to, no? Yung phi sub 1 na to, may requirement yan. Okay, if you take a look at this one, okay, so tingnan mo natin number 2. Okay, this one, properties of the errors, E sub t are independent siya. So hindi dapat related si E sub t at saka si X sub t. Dapat walang autocorrelation ang X sub t, yung series natin at saka yung error term. Okay, also, dapat meron tayong tinatawag na weakly stationary. Okay, explain ko kung ano ibig sabihin ng stationary na time na series. A requirement for a stationary AR1 process is that yung phi sub 1, okay? Ito, where's phi sub 1? Class, no? Ayan. Absolute value ng phi sub 1, okay? You have the absolute value there, should be less than 1. Okay, so balik tayo sa model natin. Yung AR1 process na to, this one, ito, yung phi sub 1 na to, hindi siya pwede na maging value, okay? This cannot be this phi sub 1 here. Maging ganun yung drawing ko. This value here, ito, no? Anyway, this value here, class, should be, absolute value niyan should be less than 1. Hindi siya pa pwedeng maging 1, hindi siya pa pwedeng maging more than 1. We will explore that as we go along. Okay, so clear siya. Yung AR1 process natin, yung phi 1 na to, parang ano to parang B1 natin sa multiple regression, di ba? It's like B1. Okay, kasi yung ano natin, yung itong value na to sa multiple regression is an independent variable. Dito, class, it's a past value, log 1, ng time series natin mismo. Okay, so we can also come up with this AR2. Sige, pakisulat yung class. Ano yung AR2? I'll give you a few seconds. Sulat yung AR2. What's the AR2 process now? Autoregressive 2, which means naka-log 2 siya. Ipaki-chat class kung finish na. You should have this, no? your x sub t is modeled by, this is a certain constant, plus phi1 x sub t minus 1 plus phi2 x sub t minus 2 plus a certain error term. Okay, kindly chat please if you're done writing the model. Okay, let's wait for the others. Dalawa pa lang. So, parang practice class sa pagsulat ng model sa LaTeX ng mathematical functions and equations. Okay, it's a lot better class than just writing it na parang regular text lang. Mas maganda to kasi mas kita siya. Okay, thank you. All right, good. Thank you so much. All right. So, anong difference nito kaysa sa AR1? Well, just take a look at this, no? Kasi dito, you have now phi1 here, and you have phi2. Phi1 being the coefficient of your log1, and phi2 being the coefficient of your log2. So that's why it's called an AR2 process kasi dalawang log2. Okay, so how is this generated? No? Okay, so balik tayo sa example natin. Kunyari sa x sub t natin. X sub t is, balikan natin example natin, kunyari 100, and then 97, and then 95, and then 96. Ulitin ko tong, sorry for the writing. 96, and then let's say 94. Oops. 94. Okay, etc. No? All right. So we have another series here, x sub t minus 1. Ano is x sub t minus 1? So take note, this is t. This is t minus 1. This is t minus 2. Okay? So yung x sub t minus 1 natin will be log 1, 97 to. And then 95. And then 96. And then 94. Etc. No? So that's x sub t minus 1. And then we have another one, x sub t minus 2. And your x sub t minus 2 is log 2. Okay? So yung x sub t minus 1, bawasan pa natin ng isa, magiging ito, 95. Okay? And then 96. And then 94, etc. No? Okay, log 2 na siya. Dito na magsisimula yung log 2. Okay, so you can see now that x sub t in time series na to, this is now log 1, and this is now log 2. So we're going to make use of this time series, x sub t minus 1 and x sub t minus 2, to try to model our x sub t. Okay, so para multiple linear regression din to, no? May iba tayong, parang ito yung independent variable 1 natin, independent variable 2. And it also makes sense to use this kasi usually may mga effect yung mga previous values, like this one. So we'd like to know what's the effect of log 1, okay, this log 1 on your time series x sub t. How about log 2? How about log 3, etc.? So you can, we will be able to determine anong log ang may significant na contribution sa pag-explain kay x sub t. Okay? So let me clear our drawing once again, clear all. All right. So in general, okay, an ARP process, okay, I'm not sure if did I give this to you? I think I gave this to you, no? Did I? Binigay ko ba sa inyo yan? Nakuha. AR1, AR2, okay, ARP, no? So medyo mahaba-haba to. Okay, iaano ko na lang class. Okay, so that we don't waste on time. Control C. Let me share that with you sa chat so that you can just copy it. Kasi medyo mahaba yan eh. Okay. All right. So kindly write that. And then let's try to see what an ARP process is. So pagka sulat nyo class, paki-chat naman please kung ready na kayo so that I'll discuss. But please, if you're ready. Let's wait for the others. Take note class, ha? Dollar lang naman yun. Eh? This signifies the beginning, this signifies the end. And then it will print this one. Okay. Thank you. Yung iba, wala, hindi ko nakikita ang mag-reply, class. A few more seconds. Nakakasunod ba yung iba? LJ, nakakasunod kayo? Some of you, I don't see replying. Nawala na, no? 12. Kanina 17 tayo. Ngayon 12 na lang. $11 na lang kayo, no? So, diminishing returns. Okay, so take a look at this class. You have the mean, okay? And then you have this one, phi1 x sub t minus 1, x sub t minus 2, x sub 3 minus 3, yung phi3. And then you have here, kasi ARPP, p logs. And then the second to the last log, and then the last log, x sub p. Okay, phi sub p pala, sorry. Phi sub p, x sub t minus p plus a certain error. Okay? All right. Now, by the way, sa AR2 class, sa AR1, di ba ang condition dapat absolutely phi should be less than 1. Ibig sabihin, pwede siyang negative 0.7 or positive 0.7. Pwede siyang negative or positive pero dapat less than 1. Now, yung AR2, let me see if, hindi dito ba siya sa ano? Okay. I think it's here, no? Sa PSU, sa Penn State University. All right, let me just check if binigay ba niya yung ano? Let me see if it gave the AR2. So that's AR1. Okay, hold on class, no? May conditions naman yung AR2. Is this now AR2? There. I'm not sure if binigay niya yung AR2, no? Okay, so pag AR2 class, may mga conditions din. So hindi pa pwedeng ano lang, no? Ito yung sinasabi natin na for AR1, absolute value ng phi sub 1 should be less than 1. It cannot be greater than ano? It cannot be greater than 1. Also, the mean, okay? The mean, the theoretical mean is equal to. So we know that if we know the delta and we know the phi1, we can compute for the theoretical mean mu. And so these are important formulas. Okay, I hope dinescribe na dito yung AR2. If not, I'll just give it next time. No? Kasi may mga conditions din yung AR2. Okay? Tapos pag AR3, meron din. No? But usually AR1, AR2, mo okay na yung model unless talaga medyo complicated yung model. No? Do I have AR2 here? Walang AR2, no? So anyway, you can check class kung ano yung requirements ng isang okay, hindi binigay yung AR2. Okay? So may mga conditions din class yung AR2, no? So there are some requirements okay, for AR2 okay, which we will be discussing next time, but I'd like you to also take a look at that, no? All right, next. So we have AR process. Then we also have MA process, no? Moving average, MA1. So what's MA1? Ang MA1 naman, class, you also have your X sub T, and take a look at this, MA1, log 1, moving average with log 1. You can now see the difference. So dapat ito, sorry, it should be E. All right. So you now have here, your X sub T is modeled by log 1 error, E sub T minus 1. And then your coefficient is theta. So ito yung standard na ginagamit na sa AR ginagamit yung phi, sa MA ang ginagamit na coefficient is theta. Okay, so we have this constant plus yung error term ngayon plus yung error term ng previous yung log 1 previous. So okay, I don't think I gave this to you, then sige lang. May iba lang naman dito yung theta. Okay? Theta underscore 1, which means subscript siya. And then E underscore T minus 1, subscript yung T minus 1. All right, so this is your MA1 process. And then how about your MA2? Ganun din. Madadagdagan lang ng, so ito gawin natin, instead of W, gawin natin tong E. Okay? Ito gawin natin E. Okay, just to be consistent. Error term at T minus 1, and then error term at T minus 2. Okay, so that's your model for X sub T is equal to a certain constant plus error term at this period minus the error term the previous period and then previous 2 periods. So that's your MA2 process. And of course, MAQ. No? So notice class pag AR ang ginagamit na na log P. ARP P yung yung ginagamit na to represent your log for AR. Sa naman sa MA ang ginagamit Q. So ito no MAQ. Okay? So yung MAQ natin, okay, so I'll just give this to you. I don't think I gave this to you. Control C. And then check na lang natin. Okay, to save on time, no? Okay, so it's the same model. We have now theta 1. Okay, again, dapat yung W natin, they should be E kasi errors to, no? E, and then E. Alright, sorry, hindi ko napalitan kanina yan. So, theta 1, epsilon sub T minus 1, theta 2, E T minus 2, theta Q minus 1, yung 1 period before the last period, which is Q, no? Theta sub Q. All right, so this is now your MA process. Okay, so pag combination nila, class, so let's call this Arima. Arima P Q. P, small p, and then small q. Let's say Arima. So paano pag Arima 1-1? Okay, so combination siya, no? Combination siya ng AR process. This stands for your AR process. This stands for your MA process. AR1 process, MA1 process. So combination siya. Let's just call this delta kasi pang AR yan eh. Let's just call this a certain constant C. So it's a certain constant, combination na to ng AR tsaka ng MA process. A certain constant plus, okay, this will now take care of your, okay, Phi1 x sub t minus 1. This is your AR process. And then a certain error term, ulit to. Yung epsilon sub t na to, di ba? It's also good for your AR process and it's also good for your MA process. So yung ET na to, combination niya ng AR at saka MA. And this is your log 1 MA, this is your log 1 AR. So kapag combine na yung AR at saka MA, you call it now Arima process. So pag Arima 2-1, ibig sabihin, okay, ano ibig sabihin ng Arima 2-1? Sulat natin yan. Okay, sige nga class, I'm going to give you 1 minute. What if it's an Arima 2-1 process? How will that look like? What will an Arima 1 process look like? Can anybody please share the code for that? Uulitin lang naman yan. Volunteer, please share the code. Anyone, please? A volunteer. Jericho, would you like to volunteer? How will an Arima 2-1 process look like? Jericho? Jericho, are you still there? Sige. Okay lang, sige. Tingnan natin kung paano yung Arima 2-1. Or if anybody would like to answer also, not only Jericho, paki-share naman yung answer niyo. Jericho? And or others, please? Carlos, paki-share din yung answer mo. I-chat na lang yung code. Tingnan natin, no? Kung ano yung process ng Arima 2-1. Ito lang yan, plus. Log 2 lang ng AR process. May Arma 1-1 ka na, oh. Just follow that. Baguhin na lang ng konti. Jericho, may answer na? Carlos, may answer na? Or anybody, please? While we're waiting for Jericho, it should not take long class kasi kokopyahin nyo lang naman yung may Arma 1-1 na kayo eh. Diba? Nabago lang tong 2. Waiting for your answers, class. Okay, John, Carl, okay, thank you. Okay, sige, copyin ko tong kay John ha. Tingnan natin, no? Control C. Let's see, Control V. Okay, so all right. So C plus V1 x sub t minus 1, V2 x sub t minus 2. Okay, so this is correct, no? Yung kay Carl din. Yun lang naman, class. Nadagdag lang naman yung ano. Ito yung kay Carl, no? Alright, so, okay. Carl, nawala yung ano mo, nawala yung log 1 mo. No? So, dapat meron pang ano, log 1. Kasi pag sinabing ARMA 2-1, you have two logs ng AR process. So, meron ka dapat yung 1 at saka 2. Okay? So, alright, so this is the answer, tama ikaw, no? So, you have a constant C plus V1 x sub t minus 1 plus V2 x sub t minus 2. So this will now account for your ito ngayon yung ano yung AR2 natin, no? Pag sinabing AR2, 'di ba dalawang logs? Log 1 at saka log 2 plus 1 log of your moving average, so that's your theta. Okay? So tingnan ko lang yung answer ni ni Carlos. Lagay ko lang dito ano. Just to comment on that. So, alright. Carlos, ang mali dito, yung V2 mo, dapat T minus 2 yan. Dapat nagko-correspond yung ano, yung V1, T minus 1. Log 1 yan eh. V sub 2 natin, T minus 2. So, this should be, kung V2 ito, dapat T sub T minus 2 yan. Okay? Dapat ganyan. Pero kulang ka pa rin ng ano, kulang pa rin ng V sub 1. No? So, alright. Tama yung sinagot ni ano. Thank you so much. Who is that? Si John, no? So si John yung sumagot ng ano. Thank you, John, for the answer, which is this one. No? Okay, so once again, class, ang kulang dito sa answer dito, yung sa isa, kulang ng phi sub 1. No? Okay? All right, so let's continue. So this is an Arima. Oops. Galing ko to. Okay, yung dalawang slash pala dito, it means next line siya. Okay. So this is your Arma 2-1. All right? Okay, so how about an Arma PQ model will of course, okay, yung PQ will be order P ni AR process, kaya nga ito hanggang theta, phi sub P. And then order Q ni MA, kaya nga hanggang theta sub Q. So parang kinumbine lang natin siya. No? And then you should have here a certain constant C plus, okay? So a certain constant C plus your AR component plus your MA component. And so that's your Arima PQ. Okay. So next, meron tayong Arima PDQ. Okay, what's an Arima PDQ? So ito, again, okay, so ginawa namin to kanina. Nabaliktad, no? So I think I gave this to you, no? Okay, dapat nasa kabila to eh. Okay, so let's take a look at this class. Arima 111. So what does this mean? This is Arima PDQ. So meron tayo, alam na natin to, no? Yung AR process na yan. Ito yung MA process. And then we have this one, D, differencing. So first, mali yung spelling ko, differencing. Right? So itong nasa gitna, yung PDQ na to, yung D na to, it stands for differencing. Alright, so what does this mean? Okay, so we have a series. Okay, meron tayong time series, di ba? Yung time series natin, x sub t. Okay, that's equal to x sub 1 plus, that's your x sub t plus x t minus 1 plus x underscore t minus 2 close, okay, plus, and you have your dots, and you have your plus x sub t minus n. All right. So pumasok to. Ito. All right. So let me start first with a doble tong x sub t. Okay, so may series tayo, no? Ito yung series natin. X sub t plus x sub, hindi, but plus. Sorry hindi plus to, no? Naging plus, hindi plus yan. You're not adding the series. Okay. So ito yung series natin, class. X sub t, okay, x sub t minus 1, x sub t minus 2, and let's call this lang tawagin na lang natin siyang x sub t. Okay, so ano na lang, pwedeng big X. Parang na lang, sige, pwede na yan. So we have this series x sub t, and it consists of yung value at time t minus 1, time t minus 2, just like what I showed you a while ago. Now, pag sinabi natin magdi-difference tayo, you're creating another object. You're creating another time series, c sub t, which is equal to x sub t minus x sub t minus 1. Okay, so let me show that. So, let me annotate that. So I have this time series x sub t. Ang value siya, let's say 100, 98, 98, 97, 99, 96, etc. No? Suppose this is our time series and this is your time t minus 1, time t minus 2. So ito yung pinaka-latest na value. Now, what will be our x sub, okay? Ano ngayon yung difference data? So that will be your x sub t d, no? Difference data. So our difference data will be, okay, 100 minus 98, ima-minus ko, the difference ko. 98 minus 98, 0. 98 minus 7, 1. And then this is negative 2. And then this is 3, etc. Okay, so what just happened? Nag-create ako ng panibagong object, ng panibagong time series, and I'm calling this z sub t, which is the difference time series. So, minus ko lang, no? 100 minus 98, 98 minus 98, ito yon. So, this is now my new time series, okay, z sub t. So, when you have this, okay, t, ibig sabihin nun, hindi na x sub t yung ginagamit natin, no? It's now a totally new time series. So when you see this difference na 1, ibig sabihin yan, class, you're now modeling another time series. And that's the difference time series, which is this one. And that's different from your x sub t. So here we're calling it z sub t, which is your time series na x sub t minus yung x sub t minus 1. Di ba? So yung from 100, 98, 98, 97, 99, nag-create tayo ng panibagong x sub t minus 1, which is 98, 98, 97, 99, 96. It will start with this one, and then minus natin. Okay, x sub t minus x sub t minus 1. So that's now your z sub t. Therefore, an Arima 111 process will look like, ano na magiging Arima 111 natin? Clear ko muna. What will now be your Arima 111? So it will now be, class, okay, we're now modeling z sub t na, no? Yung difference series. And it will be equal to a constant plus phi1. Notice, class, okay, log 1 and log 1 ng AR process and log 1 ng MA process. Okay, so yung series natin na minomodel, hindi na yung x sub t, but rather, si z sub t. Z sub t minus 1 na. Okay, because you're now working with another model, no? Okay. Now for this one, okay, this should be second differencing. Kung 2 to, paano? If this was a 2, so what happens now? So pag second differencing, magma-minus ulit tayo, no? Yung z sub t, nabura ko, no? Yung z sub t natin, di ba, ano na yun, di ba, minus natin, ima-minus ulit natin siya, no? So you will have now another, let me draw that para, no, for it to be clearer, no? Annotate ulit. Okay, so ito yung x sub t natin, no? X sub t, you have 100, 98, 99, 100 ulit, 97, 96, 96, 95, etc. Okay? 95. Okay. So now, our z sub t, okay, which is actually your x sub t minus x sub t minus 1, will be, ima-minus natin to. 100 minus 98 is 2. 98 minus 99 is negative 1. 99 minus 100, negative 1 ulit. 100 minus 97 is 3. 97 minus 6, 1. 0, 1. So this is now your z sub t, your difference series. Now, pag may second differencing, okay, let me call this z asterisk sub t, i-difference ko ulit to. No? So 2 minus negative 1, that's 3. Negative 1 minus negative 1, that's negative 2. So this is negative 4, this is 2, this is 1, this is negative 1, etc. Okay, so ang minomodel na natin ngayon, ito na. Itong series na to, no? Okay? This series now, which would be equal to Arima 1, 1 to 1 will be the constant plus P1 nito, no? Nitong series na to. Plus epsilon sub t plus state 1 ng series na to. So it's now a totally different series now, no? Kasi nagdalawang differencing na tayo. Okay? All right, let me pause for a while and please feedback please kung clear ba siya, please. Okay, thank you. Okay, good. Okay, so yan na class mangyayari pag may differencing tayo. Okay, so which means that you're now working on another time series. Difference time series na to. Okay, so let me just, okay, kasi may ano pa tayo, no? We have, okay, now, ano yung mga steps para mag-arima tayo so that we can model our time series using the Box-Jenkins approach? Remember, this is Box-Jenkins approach. And this is a very powerful model. And every finance student should be familiar with this, itong Box-Jenkins approach na to. Okay, of course, step 1 is i-plot natin yung time series and check if it's stationary. Okay, so importante class kung maintindihan natin kung ano yung stationary data series. So let me quickly discuss that. What is a stationary data series? Okay, and we can find it here. Okay, pakitingnan nga nito class, pakicopy to. No? This one, itong site na to. Okay, I gave you here some sites. Control C. Okay, and okay, copy ko na lang dito. Control V. All right, and this will show us what a stationary time series is. All right, stationary time series. All right, take a look at this data set. Itong data set na to, okay, ang stationary kasi, class, dalawang klase yan. Dalawang levels yan. Number 1, okay, annotate ulit natin. It should be stationary in mean and stationary in variance. Okay? So take a look at this data set. Stationary in mean siya, ibig sabihin nun, wala siyang trend, hindi siya umaakyat. If you take a look at the average, so ang average na ito yan, di ba? Across time, pareho yung average siya, hindi nagbabago. If this was going this way, nyari gumaganon siya. Tumataas, di ba? If this was going up, then hindi siya stationary in mean. Kasi if I take a look at this one, ang average yan, ito. Pag dito sa point na to, this segment, ang average niyan, ito na, tumaas na, no? Ito, class, across time, di ba? Hindi nagbabago yung average, ganun pa rin. So this is stationary in mean. Okay, and also, stationary in variance. Ano ibig sabihin stationary in variance? If you take a look at our data, yung ano niya, yung variance niya, yung variation niya, hindi naman nagbabago, no? It's not something that's like this. Parang na-discuss natin sa ano. Okay. Pag ganito kasi class yung ano, yung variance natin, yan, di ba? Umaakyat across time. Dito ang variance mo, ito. Pagdating dito na yung variance mo, malaki na. Okay? So in this case, stationary in mean siya, stationary in variance. Therefore, okay, stationary yung time series na yan. When we look at, okay, it's almost time, class. Tapusin ko na lang to, ha. All right. So, okay, take a look at this, class. Ito, non-stationary to. Bakit non-stationary? Kasi yung average, yung mean niya, nagbabago. Di ba? May trend siya, bumababa yung trend niya. Pag may trend, class, whether it's increasing or decreasing, hindi stationary yun. Tapos dito, tumataas naman. No? Dito, bumababa. So ito, non-stationary in terms of mean. And then, okay, maybe let's take a look at the other one, class. The other site that I gave you, ito, kunin nyo na lang doon, ano? So ito stationary. Ito hindi stationary kasi may trend siya. Ito din hindi stationary in variance kasi, di ba, nag-i-increase yung variance mo across time. Okay, ito din hindi stationary kasi yung covariance niya, dito at this point, masinsin, dito hindi. So this is the only stationary data set here. Ito hindi, may trend. Ito hindi, nagbabago yung variance. Ito, nagbabago yung covariance. All right. So, why is it important for us to make sure ito hindi stationary, no? Kasi may trend. Hindi rin stationary in variance kasi nagbabago yung variance, oh. Dito pababa. Dito pataas. Dito ang taas ng ano, saka yung trend dito, no? So, it's important for us to pag hindi stationary yung data natin, okay? Should be constant. Yes, correct. Thank you, Carlos, no? So dapat yung mean at saka variance constant over time. If it's not constant, then we have a problem with stationarity. No? Okay. So next meeting, class, we will work on the Apple stock. Okay, and then we're going to model yung Apple stock natin. So malamang yan, kasi pag kinuha natin Apple stock niyan, nag-i-increase or decrease yan across time, malamang yan hindi stationary. Okay? So how do we address stationary? How do we make it stationary? Just two things before we go, class. How do we make a time series stationary? Okay, andi dito yan, no? Ito. So please review this. Okay, pag hindi siya stationary in mean, pag nag-i-increase siya, then ang gawin natin, i-difference nyo. Because the differencing will remedy yung trend. Okay? So that's why we difference our data. Bakit tayo nagdi-differentiate? Kasi kung hindi stationary yung data, kailangan natin gawin yun. Okay, that's why you have the PDQ. So it's a tool by which we can convert the data to become stationary. And we said that the data should be stationary for us to use Box-Jenkins approach. Hindi tayo pwede mag-Arima, no, kung hindi stationary yung data. Okay, paano kung variance naman, no? Kung hindi stationary yung variance, ang pwedeng transformation natin, ilolog natin. Okay? So, ano mauuna, class? Kunyari, hindi stationary in mean and stationary in variance. The first thing that you do is, ilog transform nyo muna. Huwag nyo i-difference. Kasi pag nag-difference kayo, tapos mag-log transformation kayo, magkakaproblema kayo. Kasi pag may differencing, magkakaroon kayo ng negative answers. And then, hindi nyo na siya pwedeng ilog. Kasi you cannot get the log of a negative number. So what do? You first get the log transformation and then get the difference. Okay? So that's the time that you're able to convert into a stationary data series. All right? So next meeting, itutuloy natin to, no? And then just keep on reading this and we're going to use the Apple stock. Okay, so all right, so stop recording ko na.